Good day, folks. Welcome to my YouTube channel. Today we're going to look at the graph questions of momentum. Check my previous video about the momentum, the introduction to momentum. Now, this question, it says a trolley X with a mass of 1.2 kg travels 8 meters per second east, and it collides with a trolley Y with a mass of 0.5 kg, which initially at rest. Now, if you look at the graph here, they already chose the direction for us because this is the positive direction, this is the easterly direction. So east is positive here. So we choose east as positive, and now this velocity of trolley X, this is an initial velocity of trolley X, and this is the initial velocity which is at rest, the initial velocity of trolley Y. It's 0. The initial velocity is 0 there. The initial velocity for trolley X is 8. Now it says ignore the effect of friction. This proves that the system is what? Is isolated or closed. It's a closed, isolated or a closed system, right? What does it mean? No external forces. So friction is an external force. It says now the graph of velocity time graph shows the velocity of the trolley before and during and after collision. So if you look at this graph only show the velocity of trolley X before collision. This is the velocity before collision. So let's say this is V initial. So it was moving at constant velocity before collision for 20.1 seconds, and here this is during collision. This is the time of collision from 20.1 seconds to 20.2 seconds. This is the time of the collision. This is the contact time, or this is the time they were in contact, trolley X and trolley B, and trolley X and trolley Y. And then after collision, here's the velocity. It has decreased. If you look at it, was moving at a constant velocity of 8 meters per second. During collision, it has decreased to what? To 4. And then it moves by a velocity of 4 meters per second after collision. Right now, this graph, guys, it shows for one trolley X the before and after. So this is the velocity after, and this time on the graph, this is what? During collision. And during collision you can calculate the contact time, you can calculate the change in V, the change in velocity, and even the change in momentum you can get during that time between 20.1 and 20.2 seconds. Okay, now let's answer the questions. 4.1, it says state the principle of conservation of linear momentum. Guys, it's strictly exam guideline when it comes to that. It says the total linear momentum in an isolated system remains what? Constant. Stick to the exam guideline, it's very important. Now 4.2, calculated the magnitude of the velocity of trolley Y immediately after collision. Guys, if you're looking here for trolley Y, we have the velocity before collision and the velocity after collision, and then for trolley X, you have velocity before collision and velocity after collision, and then for trolley Y you have only the velocity before collision. So if you have three velocities and you're looking for one, so you can use the conservation of momentum. So 4.2.1, I'll say the total momentum before is equivalent to the total momentum what? After, because the system is closed. So we'll take the mass of trolley X multiplied by the initial velocity plus the mass of trolley Y multiplied by the initial velocity, its initial velocity. And then after collision, we are not told in the collision they moved off together. After collision, they collide and rebound. So we have a mass of trolley X and its final velocity, and the mass of trolley Y and its final velocity. So we're going to substitute there. We're going to substitute substituting there, it's very important to be mindful of directions there. So the mass of trolley X, it's 1.2, and trolley Y, it's 0.5. So it's 1.2, the velocity, it was 8 initially, and then the mass of trolley Y 0.5, and its initial velocity, it was addressed, and then the mass of trolley Y X, it's 1.2, and its final velocity, it's still in the same direction, which is 4, so it's going to be positive 4. If you look in the graph here, they're above the x-axis, so which is there's the same direction, so it's positive 4 and the positive 8 there. So for trolley Y, we want its final velocity. It's a final velocity there, so it's the mass, which is 0.5, and the v final, that's what we want there, v final for trolley Y. So what we're going to have there, if you punch that in the calculator, all of that calculation, guys, I'm not gonna waste time on that. So here it's going to be 4.8 and 0.5 v final, and then this side is going to be 0, and then if you punch that in the calculator, if you say 1.2 times 8, it's going to be 9.6, and then you say 9.6 minus 4.8, and you all divide by the v final, which is the 0.5. If you say 9.6 minus 4.8, and then you divide by 0.5, and then your v final there, it's going to be let me do it again, 9.6 minus 4.8, answer divide by 0.5, it's going to be 9.6 meter per second to the east. That's the velocity of trolley. That's the velocity of trolley Y, final velocity after collision. Now 4.2.2, if we really it says an average net force that trolley X exert on trolley Y during collision. So here, if you want the force, the average force that trolley X exert on trolley Y, you can use the quantities that you are given for trolley X, and you can also use the quantities that are given for trolley Y, because they're exerting the same force on each other but in opposite direction. But now I'm gonna use it for X. I'm gonna use things of X. So I'm gonna use the formula that says F net is equal to F net times change T is equal to change in momentum. So I'm looking for the F net here. I have time, which is the change in momentum. I will calculate that. So let me substitute now. Okay, this is going to be F net. The change in momentum is going to be mv final minus mv initial divided by change in t. So now I'm substituting. The mass of trolley X, it's 1.2, its final velocity, it's 4, and its initial velocity, it's 8, and then we divide by, very important guys, the change in time. It's t final minus t initial. Let's look in the graph. So this is the t initial and this t final, right? So we can say the t final minus t initial, we can put it here. So we'll say 20 comma, it's 20,2 minus 20,1, that will be 0.1. So if we punch that in the calculator, the answer there, it will be negative 48 newtons, right? We're looking for a force, but the force that we want, the force that acts, this force, guys, it's the force that trolley X experiences from trolley Y, but we are looking for a force that trolley X exact on trolley Y. So it's going to be 48 newtons. In which direction? East. So let's say the trolley X is this one, and then trolley Y is this one, right? So trolley X is exerting a force in this direction, but what we calculated the force that trolley Y, this is X, trolley Y exacted, this is what we calculated, the negative 48, but the trolley X is exacting what? Positive 48 in that direction. I hope you get what I mean. Guys, it was going to be the same case if you use the quantities of trolley Y, but it was going to give you positive 48. Positive 48, so you can do that in anyhow, right? There are a lot of ways to do that, guys. Let's look at the last question there. It says, is the collision elastic or inelastic? Guys, when they ask such question, it's very important to understand the elasticity, there. When the collision is inelastic, is elastic, that means that the total kinetic energy before collision is equal to the total kinetic energy after. They should be equal, the kinetic energy before collision, and when you add the collision of the trolley X and trolley Y before, the kinetic energy of trolley Y and trolley X before collision, and it should be equal to the total kinetic energy after, which is after collision. So when we talk about the inelastic, it means that the total kinetic energy before is not equal to the total kinetic energy what after, right? Let's prove that by calculation. Right now, this is a 4.3. 4.3. So we're going to calculate the total kinetic energy before. So it's going to be the kinetic energy of trolley X plus the kinetic energy of trolley Y. So the kinetic energy of trolley X, it's half mv initial square plus the kinetic energy of trolley Y, mv initial square. So the mass of the trolley X, it's 1.2, its initial velocity, it's 8 square. So, and we add for trolley Y, its mass is 0.5 and its initial velocity is 0. So its kinetic energy before, it's going to be 0. So there, the answer, when you punch that in the calculator, you will get 38.4 joules. That's the total kinetic energy before. Let's calculate the total kinetic energy after. So you're doing the same thing. This is the kinetic energy of the trolley X times by the final velocity of trolley X. It was 4 square plus the kinetic energy of trolley Y. Now the mass is 0.5, its final velocity it's 9.6, is the one that we calculated. So if you punch the entirety of that in the calculator, it's 30. If you punch that in the calculator, it will be 32.64 joules. If you look at these kinetic energy, they are not the same. So if they are not the same, you say since the total kinetic energy before is not equal to the total kinetic energy after, therefore the collision is what? Is inelastic. 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 Right? That's the final answer, guys. I hope that makes sense, and I hope you enjoy that.